based on observations and pattern. Based on observation and patterns. Let's get that right. Making a conclusion based on observations and patterns. We look at something and we try to make sense of it. I give you a list of numbers, you try to make sense of what that list of numbers are. Whether that be I give you 7 digits and you're like, oh, that must be a phone number. That's a pattern. That's an observation. You're basing it upon, like, usually 7 digits is a particular phone number. A conjecture is just telling someone what pattern you see. Coming up with a rule. Coming up with a rule based upon what you have. So a conjecture is a concluding statement reached using inductive reasoning. So a concluding statement reached using inductive reasoning. That can be as simple as it's a smiley face. That's a conjecture. Now, conjectures can be true or false. Conjectures can be true and false. We'll get that in a little bit on the backside, but a conjecture doesn't necessarily have to be true. So let's start out easy and let's just talk about sequences of numbers. Sequences of numbers. It's something that's human nature. When you see a list of numbers, you try to make sense of why these numbers are written. Why are they written? Why are they important? Is there any kind of pattern? Every one of these has a specific pattern. However, some of us might see other patterns that I don't see. There's especially one on here that we might come up with a completely different pattern than I intended us to do. But that's cool, as long as it follows some sort of conjecture or some sort of rule. So if we look at this one goes 38, 31, 24, 17. Now we have a guess of what the next number would be? Caroline? 10. Does anyone know what the next number would be? 3. Oh, I'm putting it in the wrong place, aren't I? Sorry. I was too far zoomed in. So we have 10, and then we have 3. Oof, now we go to negatives. What would the next number be? Yeah, it'd be -4. What would my next number be? Oh, I heard it over here. -11. And then what would our final one be? -18, thank you. That is our inductive reasoning. We're picking numbers. Did we say a rule yet that we have to follow? No, we all just kind of picked a rule in our head, right? What was our rule? Caroline? We're subtracting 7. That's our conjecture, that we are subtracting by 7. Now, we could put some official math things to it. We could say something like to generate the next term. To generate the next term. Subtract 7 from the previous term. Those are a little more precise rules where we all might have realized what subtract 7 meant, but subtracting 7 doesn't really tell you from what or how many. This definitely says take a term, subtract 7, and now you have your next term. Okay, let's look at the next one. The next one has 2, 5, 11, 23. I have 2, 5, 11, 23. Seems like a big jump. All of a sudden we went from 11 to 23. Does anyone want to take a guess at what the next number is? Savannah? Okay. What do you got for a pattern? Add 3, then 6, then 12, and then what would we add now? We would add how many? What would we get then? I think you have it. 47? Yep. What would the next number be? Take the time, do the math. We have calculators. Love calculators. You think you got it? 95. I'm going to let everyone catch up. So I had 47.95. Let me know if anyone gets the next one. So we have 2, 5, 11, 23, 47, 95. I think we're going to go big number. Anyone get our next term? Someone that's not in this pod, because I know they got it. $191. Did you guys get $191 over here? No? What'd you end up with? I think 191 is correct. How about our next term? Someone new. What's our next term? Whew, maybe this will be a long lesson. Guess we're relying on you guys. What'd you come up with for the next one? 383. Anyone else agree with 383? Good with that one? And then I'll give us our last one. Our last one we should come up with 767. What did we do to get those numbers? For those of us that are just like waiting for us to put the numbers down, can someone help explain what we did to get those numbers? Huh? We'll go back over here. Savannah, you want to say it again?
You add 3 and then you multiply the 3 by 2, so you're adding 5 and 3.
Multiples of 3. So what you said is basically, so we added 3 here. So that means we're adding 6 here. And then does that mean we're adding 12 here? And let's see if this holds up. Then we add 24. And then we would add 48. And then we would add 96. Is it holding up? Are we good with that? Do you know I did something different? The people that came up with these patterns, did you do this pattern? Those of us that are trying? Is that what you used? where we just kind of keep doubling because we saw it was plus 3, plus 6, plus 12. Always a good idea to write down our pluses here. I did something else. Stay with me here. What's 2 times 2? 4. Add 1, we have... What's 5 times 2? Add 1 and you have... What's 2 times 2? 22. Add 1, we have 23. What's 23 times 2? 46. Add 1, you have 47. So Savannah, you saw a different pattern, but it still worked, right? I saw a slightly different pattern, and it still worked. So we'll go with your pattern. Let's just go with, to generate the next term, maybe add a multiple of 3. Starting with the number 3. If you use my method, it'd be basically double the number and add 1. Double the number and add 1. Both of them work. Like I said, a lot of these are just pattern I'm not telling you the rule. You have to come up with the rule. And as long as your rule works for the first 4 numbers, you might be completely different on the rest of them. As long as your rule works for the first 4 numbers, you're good. Just explain how the first 4 numbers come from and then handle the rest of them. What I'd like you to do is, since we don't have a lot of participation, we're going to go ahead and in our groups, we'll do 3, 4, and 6. You will do 3, 4, and 6. Find ones that you think you know the pattern for. You don't have to do it 3, 4, and 6. Maybe you start at 4 because you're like, oh, I'm good with letters. Or start at 5. Maybe you see a pattern in 5. I would just like you, within your groups, to have a conjecture for all 3 of those. Or 3, right? Well,
Okay.
the odds are someone's going to get picked.
Okay, you said number 3?
Yep, number 3. So what are my next numbers, I guess? Let's start with that.
Just name off the next number.
Yeah.
25.
Got it.
36.
36. 49.
64.
64.
81.
81. How did your group come up with those numbers?
Okay, so because it kind of left my mind when I started working on the other.
Okay, we can always ask someone from our group to help out or read through it.
So with the next number, we added 2 to the previous number. So starting from 1, we'd add 3.
Okay.
To get 4.
Gotcha.
To get 5, we plus that. Then we get 5.
So plus 5. So basically you're adding 2.
We're adding 2 to each number.
So if I added 5, what would I add next? 7. What would I add next? 9. And then I'm guessing I would add 11. And then add 13. So we're just adding 2 to what we're adding. Did anyone do it differently?
Chris.
Oh, yeah.
Chris did it differently.
No, I didn't.
Yes, you did.
No.
I had it right first.
No, you didn't.
Did I change it midway?
Chris did it.
Okay. That's okay. If we're looking at it's not working, that's fine. Hey, I looked at it a different way. I looked at it as, what's 1 squared? What's 1 squared? 1. What's 2 squared? What's 3 squared? What's 4 squared? What's 5 squared? What's 6 squared? What's 7 squared? Well, that's 49. 8 squared is 64, and 9 squared is 81. Your pattern works though, right? My pattern might have just been a little simpler, that it's just take your nth term and square it.
I was right at first.
And I'm going to tell you,
I was
Notice how we have this first level where it's like 3, 5, 7, 9, and we go down to a second level where it's adding 2. Do you think it's a coincidence that we'd be squaring then? It is not a coincidence. If we got to like adding 3s or to a third level, we might be cubing it. So the patterns exist whether we're adding or we recognize the other thing. All right. Yep.
You start at A.
Yep.
And you skip the next 2 letters.
So we skip 2. So we B, C. So skip 2. Whoop, that says skid. Skip 2. Yep. And we get to D.
And then you get another J, and then after J,
Is it always skipping 2? Okay. And then what do we have for the remaining letters then?
M, P, S, E, Y.
M, P. Can you say that one more time?
S, E, Y.
S, V, Y. Do we all agree with that? M, P, S, U, Y? Anyone get anything different? No, that was pretty easy. It's just, you just got to know your alphabet, right? So we skip 2 letters to get to the next one. All right, our last one, I said, if you get exactly what I saw out of it, which walking around, I don't think anyone did, you put. So we stopped at 5. What would be the next number?
1,
Gotcha.
6, 1, 7.
Gotcha. How did your group come up with those numbers?
Like, we don't know how to explain it.
Oh, okay.
You just go 1 and you add another 1 to the previous one.
Okay, so are you saying like, so are you looking at like the 3, 4, 5s? Okay, so if we look at the 3, 4, 5s, when I go to 3 to 4, I add 1. 4 to 5, I add 1. 5 to 6, I add 1. And then it's got to smack some 1s in between, right? Perfect. I think I heard some groups that like figured out how to get back to 1. Like you subtracted 2, then you added 3, subtracted 3, then you added 4, which is a great way to do it because it gets you to all of them without saying you just stick a 1 in there. I'm going to do my method. I'm going to write a number above it. That's pi. That's pi. That's this big guy right here. It might take some people looking it up. Does anyone know the next number in pi? If it's 3.1415, 9 is correct.
So smart.
2. I heard 2.
6, 5,
5.
5, 5.
Are we stuck on the last one?
Yeah.
That was just 3. Yep, it was 3.141592653. Was your conjecture wrong, though? No. As long as it works for these numbers, it's correct. So when you're checking your homework, if it's not the same pattern I came up with on the answer key, don't change yours. There's no reason to erase it. Like if mine said 3.141592653, and you're like, I don't know. Why can't we just do 1, 7, 1, 8? Like do that pattern. Your pattern is fine. That's your conjecture. All right. Are we good with that? Pattern, it's just pattern recognition. All right, our next one is counterexamples. I said a conjecture can be true or a conjecture can be false. My conjecture is I'm 8 feet tall. Do you believe that conjecture? No, it's false. But you don't have to be so happy about it. All right, so a counterexample is just coming up with an example that makes it false. So the key word to counterexample is it must be an example. I don't want you to define what it is. I want you to give me an example, and it's going to show that the conjecture is false. So we need an example that shows the conjecture is false. Did I say anything about explaining why it's false? I'm just saying, give me an example of it being false. So here's my conjecture. Everyone in this classroom is under 20 years old. Is that true or false? Thank you very much. Uh-oh. I'm not under 20, right? So that conjecture would be false. And your counterexample would be Mr. Pabian. You don't have to explain that my age is obviously over 20 years old. You just have to say Mr. Pabian. So if I said everyone in this classroom is under 20-year-old, you'd put false Mr. Pabian, and you'd have the answer correct. No explanation needed. You just have to give a counterexample, something that shows that it's false. So a lot of these just have some trial and error in them to first come up with if they're true or false. So the first thing you have to do is come up with, are they true or are they false? So if we look at the first thing, it says the sum of any two consecutive integers is always odd. So consecutive just means I'm adding 1 plus 2, which would give me 3. So this is where I would take out a calculator and I would just try some quick. I'm not going to bury it deep. It's not going to be like 1,155 plus this one is that. So we just try the first couple. We do 1 plus 2. That equals 3. Is 3 odd? Okay, let's do the next. Let's do 2 plus 3. 5. Is that odd? 3 plus 4? 5 plus 6? Let's choose 10 plus 11. This is going to be true because you're basically adding an even number to an odd number, which is going to make it odd. We're not going to go through the semantics of proving it's true. We're just going to go, hey, Mr. Pabian, the first few I checked are true, so I'm pretty sure this is going to be a true statement. So we're going to go with true. Do I need to provide a counterexample if it's true? No, it wouldn't make sense. A counterexample has to be something proving it's false. If it's true, there's no such thing as a counterexample because everything works for it, so we just put true. And there's no reason to put an example that it's true because you have to put all of them. So that one's true. Our next one says the product of two numbers is always larger than either number. This is where you have to think outside the box a little bit. Because if I do like 2 times 3, it's 6. 4 times 5 is 20. Those will fit this mold. Can anyone think of an example where you multiply it and it's not larger than either of the numbers? Decimals. What if I did 2 times a decimal? Let's just pick 0.5. What's 2 times 0.5? Equals 1. Is 1 larger than 2? That's a great counterexample. This has to be a false statement because 2 and 0.5 would work. What if we try 0? What's 3 times 0? 0. Is 0 larger than 3? No. What if we try negative numbers? 2 times a negative 2, all of a sudden we have a negative 4. Negative 4 is actually smaller than both of those numbers. So here's my advice to you. If you're not sure if something's true or false, what I would go with is I would start looking at zeros, I would look at decimals, and I would look at negative numbers to see if those break it. That'd be the first thing I try to break something. So if someone told me if I multiplied 2 numbers, it's always larger than either number, I'm going to think, let's try decimals. Let's try 0. Let's try negative numbers. Those are the 3 things that usually break these. If it works with those 3 things, then you're probably fine. But look out for those 3 things breaking it. So this would be false. And we could use any of the examples that I wrote. So we can use 2 and 0.5. Those are my 2 numbers. That's my counterexample. And you can even show your work here to support it. Showing your work's good to support it. Because if you're wrong, but you showed me something that you checked something, at least I know that you were checking and you weren't just guessing at two numbers. Let's do the next one together. The product of two perfect squares. Now, I wanted to go through this one together just because I want to highlight that word. Perfect squares. Does anyone remember what a perfect square is? Well, good thing we went through this. A perfect square is what happens when you square a number. You get a perfect square. So if I do 2 squared, 4 is a perfect square. If I do 3 squared, not cubed, 3 squared, I get out 9. 9 is a perfect square. If I do 4 squared, that equals 16. That is a perfect square. So when I'm talking about perfect squares, you can use your calculator to come up with your perfect squares. You just have to know what perfect square is. And it's really easy in your calculator. You just do 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, and we can get all of our perfect squares handled nicely. So let's go back here. It says the product of 2 perfect squares is always a perfect square. So let's list a couple perfect squares. So I have 5 squared equals 25, perfect square. I have 6 squared is going to equal 36, perfect square. 7 squared is 49, perfect square. 8 squared equals 64, we got a perfect square. 9 squared equals 81, we got our perfect square. 10 squared equals 100, we have a perfect square. 11 squared equals 121, a perfect square. I do expect you to be able to do that in this class, that you know what a perfect square is, and then you can come up with this list. And you could keep going because you have a calculator. You could do your 12 squares to get your 144. You can do your 13 squares, which should give you 169. These are all things that you don't have to have memorized. You just plug it in your calculator because remember, you are required to have a TI-84 in this class. And it will come up pretty quick that we're going to start using those a little bit more, particularly in the second half of this year. And if you don't have one, you can't do the work. Okay, so now it says that the product of 2 numbers, of 2 perfect squares, is always going to be another perfect square. So let's start with this first number, 4 times 9. What's 4 times 9? 36. Is that a perfect square? Okay, cool. What other rule do we have? The product of 2 perfect squares is always a perfect square. Okay, so we should be able to do 4 times 16. What's 4 times 16? Try that in your calculator. 64. Is that a perfect square? Yeah. Let's try 9 times 16. Comes out to 144. Now, if I didn't have 144 on the list, here's all you have to do. Take the square root of it. Type in your calculator, do square root of 144, and what do we come up with? 12. That means it was a perfect square to begin with. I'm going to tell you, just to cut the story short, if you multiply any of these, you actually get a perfect square. So if you do 81 times 100, you get 8,100. You do the square root of that, and you actually come up with a perfect square. So this is actually a true statement. I just wanted to make sure we went through what a perfect square was. All right, we did this one. We did this one. I would like you to do the rest, but let's real quick, just so we know what words mean. Let's look at number 10 together. What's a vertical angle? What's a vertical angle? Yeah. They're across from each other. A vertical angle is when you have 2 lines that intersect. So we could do like 1 and 2 are vertical angles. This says they're never complementary. I know they're congruent. What does complementary mean? Yeah. They add up to 90 degrees. So this is saying these two can never add to 90 degrees. That's what that one's saying. They're never complementary, which means they never add to 90 degrees. Our last one says two angles supplementary to the same angle must be congruent. Let's go through number 11 together. I like number 11. Two angles that are supplementary to the same angle must be congruent. Two angles that are supplementary to the same angle must be congruent. Keep that in mind. So supplementary means they must add up to 180 degrees. Congruent means it needs to be the same angle. So what they're saying is two angles supplementary to the same angle must be congruent. So what I am posturing to you is, let's say this is angle 1. And then I have an angle 2. And I have an angle 3. What this is saying is if 1 is supplementary to 2 and 1 is supplementary to 3, then 2 and 3 must be equal to each other. It's actually a big deal in geometry that we understand what's happening here. So I'm saying 1 and 2 are supplementary, 1 and 3 are supplementary. I'm telling you that 2 and 3 must be congruent to each other. And I'm going to do it with hard data. Let's say this is 30 degrees. If I told you 2 and 3 are supplementary, what does angle 2 have to be measurement-wise for them to be supplementary? It would have to be 50, not 50. Okay, thank you. All right, so this would have to be 150. It would have to be 150. Okay, now I said that this is also supplementary to number 3. What does 3 have to be? What does 3 have to be? If this plus this equals 180, it would have to be 150 as well. Are both these the same measure? Yeah. Let's do it slightly different. Let's change this one to 40. If this is 40 degrees, what does this have to be? Oh, let me erase this. Yeah. Because I see 150s. I heard people say 150s. So we have this is 40. What do I add to 40 to make 180? 140. Yeah, use your calculator. What does this one have to be if this plus this equals 180? 140. Like it or not, that's a huge thing that you need to understand. That if I tell you two angles are supplementary to the same angle, these must have been the same angle to begin with. Just had to be. So that is a major true statement. I'm going to put an exclamation point on that because you need to know that fact. The same is going to be true if it's complementary. Two angles complementary to the same angle must be congruent. That would be also true. All right, I'd like you to try number 9 and 10. See if you can come up with those being true or false. And if it's false, come up with an example of why it's false.